Hey everyone, so continuing from the previous video where we were trying to examine stationary points, and I left with this example, y equals to x cubed minus x squared plus 1. And we've realized that if we want to find the stationary points, we equate the derivative to 0 because stationary points all have derivative 0. And then we realize we will get 3x squared minus 2x equals to 0. And then after all the stuff, you'll get x equals to 0 or x equals to 2/3. And I left out the video with this, well, pathetic cliffhanger of finding out whether is it a minimum point or a maximum point. And here I'd like to introduce two ways of doing it, but let's just do it the first way. It's what we call by the sign test, or the first derivative test. As you can tell by the name, we're only looking at the first derivative test. How it works is very simple. It works by comparing the shape of the graph before and after the stationary point. And we do that by looking at the gradient. The idea is that if it's a minimum point, it will be a U shape. So before that, the gradient will be negative, and after it will be a positive. If it's a maximum point, the gradient before the stationary point will be positive, and afterwards negative. If it's a stationary point of inflection, then what happens? Then the gradients of both before and after will be the same. And basically just the shape of the graph, alright? So because we're looking before and after, so therefore we have these x values. So in the middle, what we do is, okay, in the middle, we have, let's say we start with 0, okay, 0, 0. In the middle, we just leave it at 0. On the left, right, because we imagine this graph, so it must be less than 0, but it's very close to 0, so we write it as 0 minus, and afterwards 0 plus. 0 minus 0 plus means they're very close to 0, so something like 0.0001 or 0.1, but not as much as, like, let's say 2 or 3, okay? Next column, what do you write? Since the first derivative test, dy dx. And because it's also the sign test, we're looking at the sign of the gradient. So at 0, we know that dy dx is 0, so it's 0. If it's less than 1, if it's less than 0, what will be the sign? So if you were to look at the function again, the derivative again, is x bracket 3x minus 2. So if it's slightly less than 0, 3x minus 2 is negative, x will be negative, and therefore here is positive. When it's more than 0, slightly more than 0, x is more than 0, slightly more, so the inside term is less than 0, and therefore the derivative is negative. What do we have at the end? We have positive gradient, constant 0 gradient, and then negative gradient, and this realizes give us the classic end shape, and therefore at x equals to 0, then the point, well, 0, 1, because we saw x inside here, is a maximum point. If you do the same thing for 2 over 3, so we have 2/3, right? So again, 2 over 3, slightly less than 2/3. We then have 2/3. We then have 2/3 plus dy dx. Now, going back to this original, the derivative function. So if x equals to slightly less than 2/3, we have positive x. X is more than slightly less than 2/3, so it should be positive. 3x minus 2 is slightly negative. Therefore, we have a negative gradient. At 2/3, we know that dy dx is 0, so that's just 0. At slightly more than 2/3, 3x minus 2 is bigger than 0. X is more than 2/3, so we have positive. As such, what do you get? We get a U-shaped graph, right? And therefore, at x equals to 2 over 3, then whatever point it is, I'm not really in the mood of calculating, is a minimum point. All right. If, let's say, it's end up being positive, 0 positive, it's a stationary point of inflection. If, let's say, it's negative, 0 negative, it's also a stationary point of inflection. And this is the first derivative test. The other test is actually what we call by the second derivative test. So going back to the graph, so the derivative, all right, we have, well, let me just write down the first form so that we can do, so it's easier to differentiate again later. The other test, all right, is the second derivative test. And by second derivative, we're looking at d2y dx2. And how are we going to use this? Well, firstly, let's just differentiate and find the function for d2y dx squared. So d2y dx is basically differentiate dy dx again, so I get 6x minus 2. Okay, what do you do next? Okay, at x equals to 0, just put in the values. All right, at x equals to 0, d2y dx squared equals to minus 2. At x equals to 2 over 3, then it's d2y dx2 equals to 2. Okay, now what's gonna happen is something. Okay, now the logic is that when d2y dx2 is less than 0, the point is a maximum. If d2y dx2 is bigger than 0, it is a minimum. It's something like an opposite, right? Maximum means more, but its opposite, your d2y is negative. If something is little, like minimum, it should be more. It shouldn't be more, but d2y dx2 is more. But why is this so? Let me just write you the graph, alright? Consider the maximum graph first. d2y dx2, right? It's second derivative. So we know that differentiation is the rate of change, right? If we were to differentiate the gradient again, you're finding the rate of change of the gradient, correct? If you look at the gradient of the original curve, it was positive, but it gets less and less positive until 0. So it's very positive. It was a very positive gradient, very, very positive gradient, but then it started towards less positive. So it decreases, right? So from this point to 0, or to the stationary point, is decreasing. The gradient is decreasing. From the stationary point and beyond, you notice that the gradient becomes more negative. That means the value of the gradient decreases to the negative region. And that's why the change in the gradient is negative throughout. And that is why d2y dx2 is less than 0. Similar logic is applied to the minimum graph. Alright. The gradient was very negative at first, but as it approaches the stationary point, the gradient becomes less and less negative. So it's very, very negative, but it increases to 0. So over here, it increases to 0. From negative, you increase to 0. From the stationary point upwards, the gradient becomes positive. So it then becomes positive. So here is an increase in the gradient. And because d2y dx2 represents the change in the gradient, the change in the gradient from minimum point, you notice, is increasing, and therefore it is positive. And this is why if d2y dx2 has a negative value, it's a maximum point. If it's a positive value, it's a minimum point. Applying it to the example here. At x equals to 0, d2y dx2 is negative, and therefore at x equals to 0, it's a maximum point. And at x equals to 2/3, it's a minimum point. When do you use the sign test and when do you use the second derivative test? If the function is incredibly hard to differentiate again, use the sign test. If it's easy and if you're confident in doing it, go after the second derivative test. And this is basically stationary points.